Hello students, welcome back to the 8th video of this playlist. So in this video we will be solving question number 8 from P4 January 2024 paper. So you can see question number 8 is basically from proof by contradiction that is discussed in the very first chapter of your P4 textbook. Okay, so let's get started. Number 8. So the question asks here, use proof by contradiction. We need to use proof by contradiction to prove that the curve with equation y equals 2x plus x cubed plus cos x has no stationary points. Okay, before starting the answer, let's discuss a bit about proof by contradiction. Proof by contradiction. The name is what? Contradiction. What does it mean? Try to understand what does the word contradiction mean. Contradiction means telling something from the opposite. Right? Telling something from the opposite. So basically what we will do in proof by contradiction is that we will start the proof from the opposite, okay, and then we will see that the approach, we will do the algebraic workings, everything we will do, okay, using the opposite thing. We will consider the opposite thing as the true, and using that opposite fact as true, we will be doing all of the workings. So after doing workings, we will see that our workings are approaching towards something that is impossible to happen. That is impossible to happen. Okay. So as our assumption was the opposite, and doing the workings with the opposite fact, okay, we will see that something that is impossible to happen, we are approaching towards that. Fine. So then we can understand that our initial assumption was what? Wrong. We have assumed the wrong thing. That's the theme of proof by contradiction. So if our initial assumption, which was the opposite one, since the opposite one is false, if we could show that if the opposite thing was wrong, then if the opposite thing is wrong, then we can say that our actual thing that the question asked for, it will be the true. That is proof by contradiction. So in question number 8, regarding that context, they have asked for no stationary points, right? So what we will assume? We will assume the opposite thing as what? True. So in that case, what's the opposite thing? We will assume that we will what? Assume that the equation what? They said what? They said it has no stationary points. We will say that assume that the equation has at least one stationary points. Okay? We will say that the equation has at least one stationary points. Why at least? Why am I saying at least? The reason is that they said no stationary points. So if I can show that there is the given equation has at least one stationary point, then it will be like, if I can disprove, because we have considered the opposite thing here, if I can disprove that there is no stationary points. At least there is no stationary points. If I can show that, then the opposite thing. If there is at least one stationary point, then what would be the opposite? No stationary point. No stationary points. Make sense? Let me repeat. Why I wrote at least? Because they said no stationary points. That means it doesn't have any stationary point, right? So I considered at least because, why? Because if I can disprove that there is at least no stationary points, then my opposite thing of the assumption will be the true. So what's the opposite of at least one stationary point? No stationary point. That's why I considered at least one stationary what? Point. Okay. So now the concept is what? They asked for no stationary points, right? So whenever you came up with stationary points, the first thing we consider is the what? Gradient function. At a stationary point, the derivative is what? 0. So let us consider at first find out the derivative. dy over dx, it is equals to what? dy over dx, it is equals to 2 plus 3x squared. Okay, and derivative of cos x is what? Negative sin x. Negative sin x. Okay, if this is the case, 2 plus 3x squared negative sin x, we got the derivative. Now consider at stationary point, what would be the case? dy over dx would be what? Dx would be equal to what? 0. Where? At stationary point, right? At stationary point, we can write what? dy over dx equals to what? 0, right? Okay, so let's consider 2 plus what? 2 plus 3 x squared negative sin x equals to what? 0. Fine. Now let's rearrange. Okay, before I rearrange, how should I rearrange this equation? My aim is what? My aim is that I need to show that the equation doesn't have any stationary point. Okay, the equation doesn't have any stationary point. I need to show that. So in order to show that, what should be the condition for this equation? The condition for this equation should be that there's no possible solutions for this equation. Why? Because this equation represents the solutions, that is the number of stationary points of the curve. Because at a stationary point, derivative is what? 0. So the number of stationary points on the curve is the same as the number of solutions to this equation. So if we can show that there is no solution to this equation, then we can disprove our assumption. Makes sense? So in order to prove that, what we can do? At first consider. What we need to consider? The equation. 2 plus 3x squared negative sin x. Right? This is the equation. So they asked for what? Are there any limit for given for x? No. There's no range of values for x given. Nothing is given. Okay. So what we can do? We can rearrange this equation like this. Look. 3x squared plus 2 negative what? Sin x equals to what? 0. Now what conclusion I can have from this equation? Before that, let me say another thing. We assume that this equation has at least one stationary point. So if it has at least one stationary point, then we would get a solution to this equation. That means if I can show that this equation doesn't have any roots, then it will contradict my initial assumption. So I need to make a conclusion such that this equation doesn't have any roots. So let's see what I can write here. You can write here, we can write what? Sin x, right? Sin the range, consider the values, possible values for sin x. Sin x is what? Greater than or equal -1 and less than or equal what? 1. Right? Less than or equal 1. And what? 3x squared plus 2. 3x squared plus 2 is always what? Is always greater than 2 for all possible values of x. 3x squared plus 2 is always what? It's always greater than what? 2 for all possible values of what? Values of x. So what does it mean? That means the value of this equation can never be 0. The value of this whole equation can never be 0. Hence no roots. Hence the equation has no roots. Hence what we can write? Hence the equation has no roots. Fine. So it contradicts what? Which contradicts our, according to our assumption, this equation, the derived equation, the yellow marked equation, was supposed to have at least one root, but it has no roots. Okay, so that means which it contradicts, definitely it contradicts our assumption. Okay, so since it contradicts our assumption, hence proven by contradiction that the curve with equation what? So the curve with equation what? Y equals to x cube plus what? Twice of x squared, x cube, or is it x cube plus twice of x plus cos x, twice of x plus cos x has no stationary points, has no stationary points. It has no stationary what? Points. That's it. So this is basically the concept of proof by contradiction. Okay.